There are three basic ways a rig distributes or transmits power: an AC to DC power system, or SCR power system, a DC to DC power system, and a mechanical power system. At the heart of every rig power system, whether electrical or mechanical, is the prime mover. A prime mover is the rig's main source of power. Most rigs have more than one prime mover. Prime movers are almost always large internal combustion engines. Some equipment on the rig requires hydraulic power and pneumatic power. The rig's hydraulic and pneumatic systems also obtain their power from one of the three basic distribution systems. Just what is power, and how is it measured? Well, to understand power, we have to understand force and work. Think of a force as a push or a pull. If a constant force is applied over a distance, we have work. Work equals force times distance. Power is the amount of work done per unit of time. See these horses pulling their loads? The top one is moving much slower than the second. But by the time they've gone the same distance, they've done the same amount of work. The bottom one, though, finished 5 times quicker than the first. So it did 5 times as much work per second as the top one. That means the bottom horse delivered 5 times as much power as the top one. Large diesel engines are the main power source, the prime movers for most rigs. These engines often produce from 500 to over 8,000 horsepower, or 350 to 5,600 kilowatts. Rig builders usually house several engines together to drive the rig equipment. They also keep extra engine sets available for backup operations. Most rig engines are diesel because, unlike gasoline engines, they can produce a lot of power when running slow. Also, diesel fuel is not as volatile as gasoline, so it's safer to use, transport, and store. A diesel engine takes chemical energy, or fuel, and converts it to mechanical energy, rotational force, to power the rig equipment. Here's an AC to DC power system. The prime mover, usually a diesel engine, supplies power to the AC generator, also called an alternator. From the AC generator, AC current is sent to the SCR, the silicon-controlled rectifier. An SCR is a high-tech solid-state electronic device. The SCR converts AC to DC current, which drives the heavy rig equipment, such as the mud pumps, the drawworks, and the rotary system. Auxiliary loads, such as small pumps and rig lighting, need lower voltage AC power, so a transformer steps down or reduces the voltage to the rig's auxiliary electric equipment. Here's a DC to DC power system. The prime movers, usually diesel engines, power DC generators. From the generator, DC current goes through a control panel directly to DC motors. The DC motors power the mud pumps, the drawworks, and the rotary system. A smaller AC generator is also part of the system. It supplies AC current for equipment that works best with this current type. For example, a chemical mixing pump requires AC power. Here's a mechanical rig system. Mechanically powered rigs are usually smaller than those rigs which use electric power. The prime mover drives a mechanical compound transmission, which in turn powers the drawworks, the rotary table, and the mud pumps. Auxiliary loads, such as small motors, are supplied with AC from an alternator connected to the prime mover.